We've just been reviewing how differentiation and integration are different procedures using different rules. But there is a relationship between the two of them, and we're reminded of that by the fact that integration is also called anti-differentiation. And as that name implies, differentiation and integration, or anti-differentiation, are opposites of each other. Technically, we say that they are inverse operations, and this just means that they're opposites and they undo each other or cancel each other out. Let's take a look at that. Let little f of x be the function 3x squared minus 2x plus 1. We want to find capital F of x, which is the notation that's often used for the integral or antiderivative of little f of x. And then we're asked to find capital F prime. So let's try that. So capital F is the integral or antiderivative of little f. That's just kind of standard notation, which in this case is the integral of 3x squared minus 2x plus 1. Don't forget the dx. So using our rules for integration, we're going to have 3 because we keep the constant coefficient. Then we add 1 to the power on the x, so that's going to be x cubed now because 2 plus 1 is 3. We divide by the new power. And I go on, I keep the minus sign that's between my two terms. I keep the constant coefficient 2. X has an invisible positive 1 exponent, so when I add 1 to that, I get a 2 exponent, and I have to divide by the new exponent. And then plus, and the antiderivative of a constant is the constant times x. Then I have a plus c. Notice I no longer have the dx because I've done the integrating. So the dx is part of what tells you you're integrating. Once you've integrated, you don't have it anymore. Last, doing a little bit of cleanup, we've got stuff that cancel. And so I wind up with x cubed minus x squared plus x plus c. So that's the integral of little f. Next, we're asked to take that answer and differentiate it. So I'm differentiating my integral. We don't have to write this, but I'm going to write it just to emphasize what we're doing. So we're doing d dx of x cubed minus x squared plus x plus c. And differentiating that, we get 3x squared minus 2x plus 1, and the derivative of a constant is always 0. So in other words, I'm getting 3x squared minus 2x plus 1. And notice that's exactly our original little f. So when I took little f, integrated it, then took the answer to that and differentiated it, I got back to where I started. So I started with little f of x, integrated, differentiated, and I got back to little f of x. That's what we mean by saying that integrating and differentiating are inverse operations. They do exactly the opposite thing. So if you do them both, you just get back to your starting point. Knowing this is super useful because that means that you can check your integral answers by differentiating them. And if your integral antiderivative answer was correct, you'll get back to the original function when you do this.